Hi everyone, welcome to another episode of Quantum Conversation Series. My name is Ellen and I am a member of the Girls in Quantum team, an organization that seeks to provide educational resources about quantum. And today we have Carla Hermann with us, an academic of the Department of Physics of Universidad de Chile, and also Millennium Institute for Research in Optics, MIRO. Thank you so much, Carla, for joining this interview. I'm glad to have you here and that students can get to know you and your story. So, could you first introduce yourself to the audience?
Of course, thank you very much for the invitation. It is an honor for me to be here with you talking about quantum science. So for the people in the audience, I am a professor at the University of Chile in the sixth department of the Faculty for Engineering. So I am also a part of the Millennium Institute for Research in Optics.
Okay, well, that's great and also interesting. Now I have some questions for you. My first is, how did you get involved with quantum optics? Did someone inspire you?
So I think that from the very beginning, when I was a little girl, I was very excited about trying to understand why the universe was behaving like this, what we observe. And I remember that my father was asking me many questions about like why if you jump you come back to the floor, why the sky is blue, why the grass is green, stuff like that. So at some point I started to understand that the universe was, but it has something like an ordering, that some kind of perfection or laws that are like involved describing all of these phenomena. So they entered to the university. At some point in my second or third year, I don't remember, I had professors that they were working in quantum information, and so they offer grants. They offer grants start some quantum information stuff, like theoretically from theoretical point of view. So I started there, and I remember that it was fascinating to see, of course, also the lectures, quantum optics, introduction to modern physics, all these kind of things were like quite amazing for me. I was amazed by theory to understand how different it was from the classical mechanics. See all this kind of characteristics that are very counterintuitive and what's happening is quantum work. So I was very amazed about that. And then, of course, when I started to do research in the information field, this started to just up. And then I did my PhD in the same topic. And I am an expert in quantum optics. That's what I do right now.
Okay, it's good to hear that you have like a science background also, and you sound so passionate about science and quantum. Well, and now I have a question that I'm personally very interested in because I would like to study abroad at some point. So, why did you decide to do your PhD abroad, and why did you choose France?
Okay, so I guess I was my history about that is complicated because I started my PhD in Chile and then had the opportunity to start another PhD abroad. So I seek for this opportunity in the sense that I was always pushed by my professors in Chile to try to do something abroad, because we believe, I still believe that for my students, that's good for them to go abroad to learn something that we have here, and then try to come back and contribute to our country. So I think that this was a very good advice at the moment, because I wanted to do something more experimental physics, and we didn't have that at that time in Chile. It was like just starting. And so I decided France because I don't remember exactly why, but I thought that was a good country. I guess it was also a romantic idea about living abroad. And then my professor, my supervisor in Chile, he said, okay, we can try for you to go to this team because this team is one of the best ones in France. And he was joking that he had something like if someone in France is going to win the Nobel soon, it will be this group. But I didn't believe him because I thought it was just a joke. And then so we sent an email to them. And surprisingly, they were like looking for some PhD students. So I was able to do a kind of an internship for 2 or 3 months. I don't remember. And then they will decide if they accept me or not to continue the PhD over there. And everything was good. And so in 2011, I used my PhD over there, and it was very, it was an awesome experience because I was learning from other people, other culture, other tree, other language. And I think all of this is enriching some science, my life and science, of course. So it was a very beautiful experience.
Yeah, that sounds very cool, interesting. I also believe that internationalizing your studies broadens your visions for the future.
Absolutely, and not just in science, also in life. Like you learn another culture and you understand that things are different that in your country, and the world works and move and everything happens. So you start to think about like the different way that a country can work, and this is good. That is broaden your vision about life in general terms.
It gives you experience that you couldn't have had otherwise. It's really interesting. So, you mentioned a little bit about this, but I was wondering if you could explain more in depth what research of projects in quantum you are working on now, and also what has been the most difficult challenge you have faced in the field.
Okay, so today, like with a team, we have a context team here at the University of Chile, and we collaborate a lot with another professor, which is in the south of Chile, Pablo Solano. We are good friends, and we collaborate a lot. And so we have this team, this quantum team, and we have some part of the team that are doing theory, and another part of the team that are in the lab. So we are exploring different research. One of them is about how to generate intense quantum light, like macroscopic quantum light, and also how to characterize this quantum light. Because normally when you talk about quantum, you normally imagine or have in mind that quantum limit is with single photons or a low number of photons. And it will be nice to have quantum characteristics, but in intense quantum light. So normally you can have intense quantum light, for instance, 2 modes of quiz light. This has been done. So then you have powers of half a milliwatt that are entangled. So they are beams entangled, and you can quantum metrology or other kind of things. But we to go to different states, for example, to have a very large focus state, on a very large cut state or compass state, something a little different. So the last year we have been researching on that, like how to generate this dense quantum. We have 2 articles that prove that can generate that. Actually, a classical state, which is a coherent state, which is not classical. You describe it. It's a good representation of an state that has a precise phase and some intensity. But of course, it has a region that is the uncertainty region. That's the signature of the quantum world. And we have proven in this article that you can like transform this classical thing in something very quantum. and not just very quantum, but also useful to enhance quantum measurements and things like that. So we had been focusing on that. We have 2 beautiful results. And what we are doing right now, we are trying to understand how you can characterize this in quantum light and in the lab. So we are performing some simulations, some analytical approach to understand how this will work. And the idea is to then perform experiments here in Chile to try to characterize this states, this macroscopic quantum light. So this is one of the research line. The other one is to also generate bright 2-mode squeeze light in the lab. This is done by state in a nonlinear medium. So we generate this tangled state, which is a beam, is not just a photon, a beam of light. And the idea is to use these beams to do some quantum metrology experiments, and also we want to propagate them in photonic crystals also. So like in a material, and see how this light evolves in these materials, how it preserved are the quantum characteristics of this light, things like that. So kind of integrated photonics, but with quantum light, something like that. And another research line we have is that we have been working with a professor that do topology. And we were trying to understand, again, it's kind of web arrays, but with topological properties, and to understand what happened to the quantum light when it propagates in these topological systems. Like if we have found this question, it was not so deeply explored that you have some things to like enrich the community, trying to understand if this topology, we know how does it work just with the intensity of light, if it could also protect quantum characteristics, quantum features about the quantum light that is being propagated in this system. So we have been working on that too. So plenty of things, quite interesting. We are doing right now.
Yeah, it sounds interesting and like very advanced. A lot of researches. Now, there's a lot of people who don't know much about quantum and its different topics. So my next question is, for beginners interested in quantum science, can you recommend any educational resources, videos, or books to get started?
Yes, sure. So you have the Instagram, Girls in Quantum. I also have my Instagram with Quantum Carla, and I also try to make a video. I try to explain something in a very like common language. You have I like a lot. There is some books that are called like optics for babies, quantum nuts for babies, confirmation for babies. Seems a little silly, but at the end of the day, you learn. Especially you are trying to understand from like the very basics how this word is constructed. So I am a fan of this kind of books for children. And also there is another book, but I don't know how this is. I guess it is, there is an English version. It's called, in Spanish, it's called Física Conceptual Physics. I don't know exactly how is the name English of this book, but it is a very good book in general for physics. Try to explain you, it's like for the higher level, and they try to explain you the fundamental of the physics in different areas like electromagnetism, Newton, quantum, whatever. But they explain in a way that they try to make you think. Like they try to enforce the critical thinking about why this is happening, why this is the best action to, I don't know, to describe this system. So I really like that book. I think it's a very good book if you want to start looking at it. And for sure, probably you can find several videos in internet, YouTube, I just recommend you to check that the source of the video is like serious in the sense that it is a person who knows what he's talking, she or he, because you don't want to learn something and then unlearning because learning wrong and then learn again. You want to avoid that process. But I think that you have plenty. There's some books also. There is a book from Seth Haroch. I think that it was released last year, the year before. And I don't remember the name either, but it's something about the mysteries of lights or something like that. So there are plenty of books that people can read if they are interested in this topic.
Okay, thank you for those answers. So you mentioned some resources for beginners, and now for the students that would like to study more in depth, with which paper, books, or study would you recommend them to read?
So there is a book that I like a lot called Max Fox, and it's a quantum optics book, if I don't remember, introductory quantum optics or something like that. And this book is, I think is for like people that are finishing the bachelor or start master PhD. Is that level, and it's quite good. I like the way he explains things and everything. I recommend that book for my students also. Then more for the quantum, also the Serge and Jean-Michel Raymond book, which is called Exploring the Quantum, Photon, Atoms, and Cavity, something like that. I love that book. Of course, he was my boss, both of them. And I love the book is very, very beautiful. The introduction and all the other chapters, and they try to connect every base models from whatever the state of the art of the community. So I really like that book. And then there are several that are the name the same: quantum optics, introductory quantum optics, or different authors. There is one that is from Cali that I also like. And Night, another one which is from Night, also like. And then for papers, to be honest, I think that most of the, if I like the topic and I know a group that is working on that topic, I will go directly to the web page of the group and see the papers over there. Like, for instance, if someone wants about this intense quantum light that we have been proposing, how to generate and everything, then you go to the Google Scholar of me or whoever, and then start looking to the papers related to the topic. So I will say there you have Google Scholar. Archive also works, but in Archive you have to pay attention because there are plenty of material. But I say that is the best reviews. There are several papers that are like a review of a topic. So they present the advances of the topic in the last, 20 years, 10 years, 50 years, and then you learn a lot also. I would say that works.
Okay, thank you. Yeah, finally, do you have any advice for young students interested in science and quantum?
Advice. I think that I think it's an advice for like every person student to pursue science. I think that you should never lose the ability to like get amazed about nature and wonder about nature, because I think that this is the primary objective of the scientific community. We want to understand what's around us. We want to make models to understand what we are observing and to predict what it's coming to say. But the reality is dynamics, right? Because it depends on how good is your eye, in the sense that if you have a better telescope or if you have a better scope, just to see things that you never saw before, you never imagined, and then you have to come up with a new theory, with a new model, stuff like that. So I think that it is important to have this mind also, so that what we know is good enough to what we have observed. But there are plenty of things that we don't understand in the scientific community, and I think it's a good way to study science is to never lose the capacity of get inspired by the universe and try to understand how does work in every level. I try to be so attached to some theories, like understanding that they might change, that they describe the universe in some part of this universe, but not all of it. We have a theory that involves everything. So I think that will be advice to enjoy what you are studying, to wonder, to question it, and try to make it as you can.
Mm, That's really good advice because technologies are always advancing and innovating, so really interesting. Um, it was such a nice interview with you, Carla. So I really want to thank you for being here, for sharing your experience, your background, your motivation. You talk with so much passion and confidence, so it's really inspiring to listen to you. So thank you again for your time. It was an
Thank you.
interested interview.
Thank you.
Bye.